submit by this Friday.
Yes, submit by this Friday, okay?
Anyone don't have extra?
Okay, let's look at try 5. Here we have a particle moving in a straight line so that at time t seconds after leaving a fixed point O, the velocity is being described with this equation. Okay, part 1 we want to find out what is its initial acceleration. So how do we find the initial acceleration? What will you do?
dv over dt.
Okay, we will differentiate to get the acceleration, so that will give you what? Okay, so acceleration will be given by the derivative. How do we differentiate this? What do we get?
Bring down the negative.
Bring down the negative half, right? So we will get negative 40e to the power of negative t over 2. Okay? Then after that, we want to find the initial acceleration, so we substitute t equals to
0.
0. Okay, part 2, we want to calculate to 2 decimal places its displacement from O when t equals to 4. So how do we find the displacement? How do we find the displacement? What do we need to
Integrate.
integrate what?
The
Velocity, right? Okay, if you want to actually do definite integral from 0 to 4, that is also fine. Okay. But let's just do the finding the displacement equation first. So integrating it, you will get this. Then after that, how do we find c? Sub in what? T equals to 0. Okay. At the initial part when t equals to 0, right, your displacement will also be 0, since the particle is actually being measured from a fixed point O. Okay, so we will find that C is going to be 160. So this tells you that the constant C is not always equals to 0. Okay?
Can we put definite integrate?
You can.
So you put 0 and 4.
Yes. So the question wants the answer to be dp, so leave the answer as such. So if you want to do a definite integral, calculation to you, you can do it on your own. Why sometimes t equals to 0, s is not equals to 0? Because the question might be such that the time is measured from maybe a fixed point O, but the displacement might be measured from a different place. Yeah. So, like for example,
Yesterday's question is like,
how should I say? Okay, maybe sometimes if in a marathon race, okay, everybody starts at the starting point, right? But then you find that the people at the end, they don't start at exactly the same point as everyone. So you want to make sure that everybody reaches at the same point and you measure the time, right? So that's why, but the distance covered by the people at the end might actually be different. You get what I mean? Yeah. So that's why sometimes the displacement and the time might be measured differently and from a different point of view. You understand? You understand what I'm saying? Okay, for example, right? Your recent cross country, okay, there is this starting point, right? Okay, then I remember that Shijie was over here. And I remember also Alexis was also over here. Okay, then after that, I don't know who is in front because I don't see them at all. Okay, anybody who was in front, Qixun maybe because he was.
that's right.
Yeah, the first few, right? Okay. So the time that we want to measure would be starting from here, okay. But whereas if you look at, so Qixun might have covered the real 3.2 km, but whereas Alexis and Shijie might have covered maybe 100 meters more because they measured from here, from where they are starting. Yeah. So it is. That's why your t equals to 0. But then the time we measured was from here instead. But the displacement, the distance covered by them is actually different.
So s is 0.
Yeah, in this case, because the question exists. Yeah. Okay. Huh? Why? They are not stick lengths. Yeah. Okay, let's look at try 6. Okay. There is a particle traveling along a straight line passes the origin O with a speed of 10 meters per second. So they actually said that everything, your time and your displacement is all measured from a fixed point O. Okay, so it says that when passing through the origin, there is a speed at 10 meters per second already. Okay, then after that, the acceleration is given by 3 minus 2t. We want to calculate the velocity of the particle when t equals to 2. Okay, so how do we calculate the velocity of the particle? We will integrate. Okay. Okay, so the velocity will be given by 3t minus t squared plus c. Then after that, what?
Sub t equals 0, t equals 10.
Okay, so when t equals to 0 in this case, your v is equals to 10 because the question says that the initial part, there is a speed of 10 meters per second. Okay, so therefore, you'll find that upon substitution c will be equals to 10. So you will get that v is equals to 3t minus t squared plus 10. So since you're trying to find the velocity when t equals to 2, you'll find that the velocity is equals to 12. Okay, likewise, I suppose you can also use your definite integral, right? Not an issue at all. Now for part 2, how do we find the maximum velocity of the particle? Differentiate what? You have to differentiate the velocity, which actually is acceleration, right? So technically to find the maximum velocity, that means 3 minus 2t will be equals to 0. So let me just write that out. Okay, so this is the understanding that we're getting, okay, that 3 minus 2t is equals to 0. Of course, you need not actually write out very clearly, okay, what and how it comes about, okay, but I'm just writing in case some of you didn't catch what I said. Yeah, because in this case, your maximum velocity when you come to the maximum velocity acceleration is okay, so t is equals to half, then after getting t ready, we will be able to substitute in to find out what is the velocity value. And we get 12.25. Is that all? Is that all that we have to do? Okay, we must prove that it's maximum. So how do we prove that it's maximum? Second derivative of velocity. So d2v over dt square will be actually negative 2. Since you're looking at the acceleration expression itself to differentiate, so it's less than 0. So therefore, the maximum velocity is 12.25 meters per second. Alright? I differentiate the acceleration because the first derivative is the acceleration. Okay. Next, part 3. The displacement of the particle from O when it is at rest. How do we find the displacement of particle from O when it is at rest? Okay, when it is at rest, the velocity is equals to 0, yes. So we can do that first. Okay, so that would give us that the at rest part is happening when t is equals to 5. Okay, but then we are trying to find out what is the displacement. How do we find the displacement? Shalom, how do we find the displacement?
Integrate.
Integrate what?
The speed.
Okay, we integrate the speed, or rather the velocity to be precise. Okay, so you can find the equation for the displacement, or you can actually do the definite integral from 0 to 5, since you already know the time. Okay, so when t is equals to 5, wait, sorry, you need to find c first. Okay, so when t equals to 0, displacement is actually equals to 0, so therefore c will actually be 0 as well. Original displacement, then after adding up 45 and 5 over 6 minus 42. That the average speed is 8 and 5 over 18 meters per second. Are there any questions? Any questions? If not, okay, could you all do exercise 20.1, question 15? We'll go through at about 10:58.
So is this standard question?
This
Standard
Yeah.
deviation.
more or less, yeah. Right? Kinematics very standard question one. Yeah. The only trickiness you can get, or if ever there's a word like that, okay, it is if the time and the displacement start at a different location. Yeah. Media was like that. So that is the only difficulty that is, I guess. The answers for part 1, 2 and 3. Are there any problems? Okay. Usually for people who are trained in physics, this should be fine. Okay. Huh? What? Why you cannot do physics? Then too bad. Let's just do one more. Any problems or not? No, right? Okay. I want you all to do exercise 20.1 question 18 as well. Is this the last question? No.
We still have one more minute.
Yeah.
But maybe you can give
I still have 2 more questions.
go through. Not last.
I want
Okay. We have hope.
做功课。
我看谁是谁，这是第一个学我
Okay, could you all do question 18?
What the hell is this?
There can be negative acceleration.
Well, the constant is two timings, right? Okay, the question have to be what's
when S equals to 0.
Not based on
Then you factorize out. Then get T equals to each.
whoa.
Any questions? Yeah.
Please infer from part 1 that
Infer from part 1.
when V equals 0, I want to get
Oh, that V equals to 0, then you take that that it means that it's returning to your original. Okay, are you all done with this? Okay, could I just explain certain things? Okay. For part 1, any problems? Part 1. Okay, for part 2, right, the question actually wants you to find out the total time that particle takes to return to O. Okay, returning to O itself, if you think about the whole question, you will think that returning to O means that S is equals to 0. So you need to actually solve it to find that T equals to 0 and T equals to 2. You cannot, okay, actually infer that because velocity is equals to 0, then T must be equals to 2. Okay, or rather, you cannot think that at the origin itself, the velocity will be equals to 0. It is purely coincidental. Okay, so it is not right for you to infer, okay, that T is equals to 2 for your part 2's answer. Right, you must think according to the context, the information given in the question. Okay, so it's purely coincidental. Okay, then after in part 3 itself, you need to find out what is the minimum velocity. Okay, minimum velocity does not always have to be negative. Okay, in this case, what does the negative means? It is a direction. Okay, so the minimum speed itself is actually 1 1/3. Okay, but the minimum velocity is negative 1 1/3. Right? Any questions? Charlotte, do you catch what I just said? Okay, later on I will go through 2 more questions, then I will return to you your homework, okay, or whatever that I have been owing you, okay, except for the more recent ones. Okay, then after once I am done with that, then I'll just dismiss you. Tomorrow we will go through, we'll start on Emacs, okay, so that means Kinematics done already. Okay. Later on I will give lah. Okay, later on I just go through 2 more questions. Yeah, what?
I thought it's good. I think
20.1 is the only unit for chapter 20.
oh really?
Yes. No, we still have chapter 10, which will be covered in the June holidays. Okay. Take note, okay, I have said it a few times already. June holidays, our lessons or the blocked out time, okay, by the school is the first week and the last week. Okay, so do not travel during the first week of June holidays as well as last week. First week you shouldn't travel lah because you have your O-level mark now. Okay, and then after that last week, okay, that is your remedial, right? Yeah. Okay, so then after that the middle 2 weeks you want to travel, yeah, by all means you can. Okay, then then after that AMATS integration test. Okay, looking at all these dates, right? Okay, I think it probably affects 1/4 of you. Okay, I think I'll just push the AMATS test to week 4 instead. Okay, so that we have differentiation test this week. Okay, then after that integration test 2 weeks later. Alright? Are you all okay?
Oh yeah.
14 to 17.